Ben bir mühendisim. Ofiste, evde, yaşamın her alanındayım. Görülmeyen ama hissedilenim. Ben ne kadar görünmez olursam, projelerim o kadar başarıyla tasarlanmış ve uygulanmış demektir. Tıpkı sizi sizden fazla düşünen gizli bir kahraman gibi. Kahramanlık, kağıtla kalem bir araya geldiğinde geleceğe yön verebilecek kadar cesur olmaktır. Çünkü mühendislik, bilim ve doğa alanında tüm bilinenleri yine doğa ve insanlık için kullanmaktır. Tasarımda sadece estetiğin değil, sürdürülebilirlik, enerji verimliliği, çevre duyarlılığı gibi kavramların da altını çizmektir. Mühendislik, modern, konforlu ve doğaya saygı gösteren yenilikçi yaşam alanlarını hayal etmek ve gerçeğe dönüştürmektir. Gelecek kuşaklara yön vermektir. Binlerce yıl önce bir kıvılcımla yaratılan aydınlığı bugün tek bir tuşla milyonlarca insanın yaşadığı yerlere taşımaktır. Geceyi gündüze, soğuğu sıcağa, sıcağı soğuğa çevirebilmektir. İnsanlığın ihtiyaçlarını karşılamak için hayallerimizi gerçekleştirirken yanımızda TTMD vardı. 1992 yılında kurulduğundan bu yana çatısı altında güven bulduğumuz, etik değerlerin teşkili ve temel sorunların çözümü için birlikte çalıştığımız yol arkadaşımız. Farklı disiplinlerden gelen profesyonellerin ortak amaçlar için toplandığı TTMD, üyeler arasında iletişim ve tartışma ortamı yaratıyor, bilimsel ve teknolojik yayınlar yapıyor, üniversite, sanayi, işbirliğine destek veriyor, çevreci ve enerji verimli çözümlerin yaygınlaşmasını destekliyor, yurt dışındaki gelişmeleri izliyor ve sektörü yurt dışında temsil ediyor. Bizler tüm insanlığın iyi yaşam arayışına çözüm buluyoruz. Bizler yarınlarımızı şimdiden kuruyor ve daha sürdürülebilir bir dünya için çalışıyoruz. TTM'de 1992'den bugüne yaşam mekanlarında insanlığın konfor ihtiyaçlarını doğaya saygı göstererek sağlamak için var. Mühendislik mesleğini etik değerler doğrultusunda uygulamak için var. Türk Tesisat Mühendisleri Derneği. Gelin geleceği birlikte yaratalım.
Daikin doğru hava uzmanı.
GF Hakan Plastik'ten GF Aqua System PPRCT. Bina içi tesisatlarda gelinen son nokta. Bir kez yap, tam yap.
Merhabalar değerli katılımcılar. Ben Arkun Andıç. Hepiniz bu haftaki TTM'de webinarımıza hoş geldiniz. Bugünkü konumuz farklı ısı geri kazanım sistemleri, yeni regülasyonlar ve teknolojik gelişmeler olacak. Bununla ilgili uzman arkadaşımız Bay Ricard, kendisi Systemair'da ısı geri kazanım sistemlerinden sorumlu direktör, globalde çalışıyor. Ben fazla sözü uzatmayacağım. Kendisini tanıtması için sözü kendisine devredeceğim. Webinarımız İngilizce olacak. Bir simultane çeviri olmayacak zamanı verimli kullanabilmek adına. Ama sorularınızı lütfen Q&A bölümüne yazmanızı rica ederim. Türkçe veya İngilizce olursa biz çeviririz. Webinar sonunda soruları cevaplamaya çalışacağız. Şimdiden katıldığınız için çok teşekkür ederim. Hello Ricard, I would like to give you the word in the beginning. So I have made a very short introduction about you and the topic of the seminar today. I don't want to take it that long and then give the word to you as fast as possible. So you better introduce yourself to our attendees, which are at the moment, the participation is increasing, but at the moment we are more than 70 people. So good luck.
Thank you very much, Arkun, and thank you very much also for having me at this webinar. My name is Rickard Lindbom, and I am Product Area Director for the Energy Recovery Systems at Systemair. I am located in Sweden. So I hope that you can all see my screen now. Good. So this is the agenda for today's webinar here. Not particular in this order, but all the topics will be included. It's the four main energy recovery systems in air handling units, technical developments, eco-design regulation concerning energy recovery, and we will have some case studies on this as well. So let's start with the energy recovery systems. The four main systems in Europe are the runaround coil system, and according to Eurovent statistics, it represents approximately 4% of the total air handling units sold in Europe in 2020. The compressor system, or the heat pumps, it represents approximately also 4% of the total air handling units sold. The main market for this system is Northern Europe, where it represents 11% of the air handling units sold. Plate heat exchangers represent approximately 34% of all air handling units sold, and the rotor heat exchangers represent approximately 32% of the air handling units sold. In Northern Europe, it represents 62%. So let's go a bit into details with every system, and starting with the runaround coils. The principle of the operation is that water with an antifreeze additive is used in the circuit, which is pumped between coils, transferring energy or heat from the coil to the other coil, and vice versa, depending on the situation. The construction is made of copper tubes with profiled aluminum fins. To vary the capacity, the copper tubes can be in different size, and the aluminum fins can be with different spacing. It is also possible to increase or decrease the number of rows. In high corrosive environments, the fins can be in another alloy or even in another material. The main pros and cons are that the supply and exhaust can be in separate places, meaning full separate airflows and no leakage. It can be used with different materials of supply and exhaust air, meaning that it can be used to recover energy from process and toxic air. However, it is difficult to get high efficiency, and there is no possibility to get humidity transfer. It could be glycol leakage, and there is usually expensive piping and pump systems included. The heat pump This system is mainly used together with the rotor heat exchanger, and the rotor can be placed between the coils or on the cold side of the coils, depending if the main purpose is to cool or heat, or depending on what climate zone you're using the unit in. The principle is that you need to have a little bit understanding of the main four components. And that is the compressor, first of all. And the compressor uses electricity to heat the gas, and energy is added to the process. In small units, we have one compressor, and in larger units, we can have several compressors. The compressor can regulate capacity to meet the temperature and airflow demand. The condenser is the coil that will receive the warm and compressed refrigerant gas from the compressor. The coil is always hot and it will heat up the airflow in the air handling unit. The refrigerant gas condensates during the passing through the condenser coil because the airflow in the air handling unit will cool the gas at the same time absorb heat to the airflow that supplies the building. The expansion valve is always placed between the condenser coil and the evaporator coil. The valve is equipped with a spring so refrigerant gas and liquid mixture is relieved of pressure with passing through. When the pressure decreases in a fluid, the boiling point also decreases. And this allows for the refrigerant to boil and evaporate at a lower temperature, which is needed in the evaporator coil. The evaporator is the coil that receives the cool liquid refrigerant after the expansion valve. This liquid refrigerant evaporates into gas, and the evaporation draws energy from the surrounding coil material, so the coil will become cold. This coil is always cold, and it will cool down the airflow in the air handling unit. Notice that only gas and no liquid is leaving the evaporator towards the compressor. So only compressor will have gas to compress. Energy is added to the system from the compressor. So example, 1 kilowatt power consumption. And in the condenser, energy leaves the system as heating of the airflow. Example, 5 kilowatt heating. The COP of 5 that heat pump delivers means that heat pump delivers 5 times the energy consumed by the compressor as heating power to the airflow. The main pros and cons with this system are that you have high total system efficiency. Cooling and heating or heating for comfort levels can be added to the building from one system. Build heat in heat pumps saves space compared with external heat pumps. But there are some moving parts, drive belts, compressors, etc. And there could also be leakage coming from the rotor. It usually requires large power installation because of the compressor, and it also requires service on the refrigerant system. The plate heat exchangers, they consist of aluminium plates with a special profile surface. The plates are so suited that each plate has a warm and cold side. The plate distance depends on the unit size, requested efficiency, and pressure drop. And leakage is less than 0.5% at 250 Pascal pressure difference. The difference between cross-flow and counterflow heat exchanger can be seen in the picture. In the counterflow unit, there is a section where the airflow meets in counterflow. And in the cross-flow, the heat exchanger, the airflow meet in cross all the time. As a rule of thumb, 70% of temperature efficiency is created in the counterflow part, and 70% of the pressure drop is created in the cross-flow part in a counterflow unit. The efficiency of a plate heat exchanger is depending on the condensation of the exchanger. Therefore, we have two different expressions. Dry efficiency which shows the efficiency without condensation, and temperature efficiency, which shows the efficiency with the condensation at the actual data for the airflows. In the graph, there is an example of difference between dry and actual efficiency depending on the extract air relative humidity at outdoor air temperature of -15 degrees and extract air temperature of 22 degrees. So at 40% relative humidity, the difference is approximately 6%. One of the usually mentioned negative factors with the plate heat exchanger is the freezing. Ice buildup always starts in the cold corner of the exchanger, and it can be avoided by usually these three main methods: bypass of outside airflow, preheating of outside airflow, or stop or reduction of the supply fan. The main pros and cons with this system are that you have a high efficiency. There is no leakage or very low leakage anyway, but there could be freezing problems. Usually there are no humidity transfer. However, this starts to come to the market. The air handling units get long at big airflows, and the counterflows, they are limited in size so far. It could be difficult to clean if the units are big. Now we will talk a little bit about the rotor heat exchanger. And the rotors consist of thin corrugated and plain aluminium foil winded on a core. The diameter of a wheel can be up to 6 meters. The wheel rotates between 10 to 20 laps in 1 minute. This means that it stays in the warm airflow between 1.5 to 3 seconds before it rotates into the cold airstream. In general, you can say that the temperature efficiency is depending on the aluminium area in the rotor. However, the front air velocity also has a major impact. As a rule of thumb, the top temperature efficiency is in the range between 1.0 and 1.5 meters per second in rotor phase velocity. The rotation per minute also impacts the efficiency. The dotted line is the humidity efficiency development, and the full line is the temperature efficiency. So you can almost halve the humidity efficiency without reducing the temperature efficiency by decreasing the rotor RPM. Eurovent certification defines rotors in 3 categories. It's condensation, enthalpy or hygroscopic, and sorption rotors. The sorption rotor is defined as a rotor demonstrating a humidity efficiency which is at least 70% of the temperature efficiency under all test conditions with normal airflow rate. A condensation rotor is an aluminium rotor, usually in the 1000 alloy series. The enthalpy wheel is usually produced by oxidation of the aluminium or active coating on the aluminium foil in every second layer of the wheel. The sorption rotor has an active coat on the aluminium foil for sensible and latent energy recovery. There are mainly 2 different coatings used. It's silica gel and molecular sieve. Silica gel has a linear increase of absorption capacity and almost double capacity than molecular sieve at 100% relative humidity. A molecular sieve has a high absorption capacity already at low relative humidities. There are, the preferred solution in Europe is the molecular sieve. There it is possible to define the pore size By using potentium, we can make the rotor selective on water vapor only, the 3-Ångström molecular sieve type. That means it will reduce the transfer of VOC gases. The advantages with sorption rotors are that it will lower the cooling capacity in the air handling unit by dehumidification of the supplier before the cooling coil. Then a smaller cooling equipment and cooling installation is needed. It will be energy saving during summer conditions and higher humidity recovery in winter conditions, and that means a better indoor climate and less humidification needed. There is also lower risk of freezing in wintertime due to less condensation. Now a case study in Central Europe summer conditions with 33 degrees and 50% relative humidity. The inside conditions is 25 degrees and 50% relative humidity. Airflow used in this calculation is 36,000 cubic meter per hour, and the rotor diameter is 3.1 meter. I have calculated a condensation rotor with 77.8% in temperature efficiency. The sorption rotor with same wave height is a bit less in efficiency. In this example, it's 1.5% less. The humidity efficiency differs 72.4%, as the condensation wheel do not have any humidity recovery at all. The sorption rotor has higher pressure drop, 32 Pascal in this example due to the coating material. The enthalpy differs 11 kilojoule, and this results in a cooling capacity saving of 13.2 kilowatt per cubic meter per second of air. There is also an increase of power consumption due to the pressure drop increase and due to the temperature efficiency decrease of 0.83 kilowatt per cubic meter per second of air. The conclusion is that even with these old prices of components, the investment cost in sorption technology is less than additional cost in cooling equipment. And so that means that energy saving or profit from the beginning. So where to use this sorption technology then? Well, where installation where cooling is required. Installation where peak load management is a topic, or whenever humidification of supply air is required. Existing installation where chillers capacity is limited and it can be a problem in summertime. So now follows a presentation about leakage in the rotary heat exchangers. Leakage occurs through sealings, central beam and periphery from one airstream to another, or bypass leakage through the sealing in the same airstream, or through purge sector. It can be carryover, air carried in the storage matrix from one airstream to another, and leakage of the casing to and from outside. Eurovent has defined two different types of leakages. It's the outdoor air correction factor, OACF, and the exhaust air transfer ratio, EATR. OACF is the air going from outdoor to exhaust through sealing and or purge sector. OACF increased the exhaust fan power consumption. Please note the different naming of the position at the rotor. 21 is the outdoor air, 22 supply air, 11 extract air, and 12 exhaust air. EHR is the air going from extract to supply through sealing and or in storage matrix. The air transfer in storage matrix is also called carryover. This leakage is measured with tracer gas. And note that only carryover can be influenced by stopping the wheel. In the diagram, you can follow the relation between the OACF and EHR. When pressure difference 22 minus 11 increase, the OACF increase and the ETR decrease. It is not possible to reach zero on both leakages. The purge sector function is to empty the rotor storage matrix on extract air, meaning decreasing the carryover. The purge sector size depends on the air velocity. If you have lower air velocity, larger purge sector is needed. The rotation speed, higher RPM, a larger purge sector is needed. Pressure difference, if you have less pressure difference, a larger purge sector is needed. The matrix of the rotor, if you have a thicker matrix, a larger purge sector is needed. On this slide, you can see the leakage influenced by the purge sector. If you increase the pressure difference 22 minus 11, you are getting closer to zero in EHR, but at the same time the OACF will increase. And here follows an example of leakage in a rotor when it is included in an air handling unit with different fan positions. This example comes from an outdoor unit, and the conditions are as follows. On the extract side, you have a duct system with 250 Pascal. You have an inlet of 7 Pascal, filter 86 Pascal, and a rotor of 157 Pascal. On the supply side, you have an inlet of 7 Pascal, filter 117 Pascal, and the heat recovery is 157 Pascal. In all 4 examples, we have promised the customer 13,000 cubic meter per hour of fresh air. So let us start with the example on the top left side. In this setup, we have 2 fans suction the air through the rotor, and the pressure difference 22 minus 11 is 62 Pascal. The unit is equipped with a purge sector, which gives us 1% in EHR leakage. The OACF is 1.05, which also will increase the exhaust fan power consumption. We need to set the supply fan on 13,130 cubic meter per hour. Now to the top right example. In this setup, we have 2 fans pushing the air through the rotor. The pressure difference 22 minus 11 is 246 Pascal. The unit is equipped with the purge sector, which gives us 0.1% in EHR leakage. The OACF will increase to 1.09 due to the fan position, and we need to set the fan on 14,183 cubic meters per hour. Now to the bottom left example. In this setup, we have the supply fan suction the air through the rotor and the exhaust fan pushing the air through the rotor. In this example, the pressure difference 22 minus 11 is minus 438 Pascal, and we cannot use a purge sector. The EHR leakage is calculated to 5%, but please remember that this condition is not tested in the Eurovec program for rotors. And the OACF is calculated to 0.95. We need to set the supply fan on 14,300 cubic meter per hour. Now the last example on the bottom right. In this setup, we have the supply fan pushing the air through the rotor and the exhaust fan suction the air through the rotor. The pressure difference 22 minus 11 is 746 Pascal. The unit is equipped with the purge sector, which gives us 0% in EHR leakage. However, the large pressure difference also creates a large OACF leakage of 1.14. Due to the fan position, we need to set the supply fan on 14,820 cubic meter per hour. And the conclusion is that we prefer the top left setup. This has the lowest total leakage and lowest fan power consumption. So the reason for leakage can be wrong pressure difference between supply and extract, poor sealing, or non-adaptive sealing, or no purge sector. But other types of leakage can also occur in the air handling unit. The position of outdoor and exhaust air can create contamination. Leakage due to overpressure exhaust to supply if the unit is delivered as a monoblock. And the leakage can come from intermediate walls or door panels, cabling and controls due to, for example, drilled holes, but also from components such if you use plate heat exchangers. But the main pros and cons with this system are that you have a high efficiency, humidity efficiency is possible, no freezing in most of the regions, low space is needed, you have a self-cleaning function or feature, it can be delivered in all air handling unit sizes, but we have some moving parts, the motor, the belt drive, there is a leakage risk, and it requires consideration of the fan position in the air handling unit. Now understanding the upcoming European Union regulation for ventilation units. The short agenda is the highlights of the current Ecodesign Regulations 1253 concerning heat recovery and what is expected due to heat recovery efficiency in the new regulations, and also what is expected due to the internal leakage. I would also like to state that this presentation only recovers the non-residential ventilation units and bidirectional ventilation unit, meaning supply and extract both, and with heat recovery, the rotor heat exchanger. The current regulations requires a heat recovery efficiency of at least 73%. And this is based on a mass flow, a balanced mass flow and dry efficiency in all units with thermal bypass on heat recovery. And that means for the rotor heat exchanger that it's possible to turn it off to 0 in RPM. And the expectation now is to receive compensation for humidity recovery and compensation for increased outdoor air temperature. Humidity recovery and ventilation reduce energy consumption for cooling in warm climates, and in colder climates it reduces the risk of freezing. And in the new calculation for energy efficiency, we will gain additional 8% the humidity efficiency. As an example of rule of thumb, you can use additional 100 Pascal in pressure drop if your heat recovery performs 70% humidity efficiency at these stated conditions. The efficiency demand is depending on the outdoor air design temperature. From -14 degrees and lower, it is still 73%. When temperature increase, the efficiency demand decrease, ending at 63.5% at plus 2.5 degrees or warmer. This is for thermal heat recovery systems. If you use heat recovery which also has humidity recovery, the calculation energy recovery limit is added with 2 additional points or percent, meaning that maximum demands goes from 73% to 75%, but you will also get an energy bonus for the SFP calculation. In the blue dotted line, you can follow the current temperature efficiency limit, and in the gray dotted line, you can follow the current SFP limit. In the light green dotted line, we can follow the efficiency demand depending on the outdoor air design temperature. However, the new regulation also adjusts the SFP limit depending on the outdoor air design temperature, and that can be seen in the dark green dotted line. The internal leakage use same definition as Eurovent and as well as the new upcoming EN 308. It is defined as the outdoor air correction factor and exhaust air transfer ratio. The requirement and design conditions for OSCF is that they must be within the range 0.9 to 1.1. Maximum allowed EHR at this site is less than 5%. For EHR below 1%, no additional compensation is needed. But for EHR between 1 and 5, the supply flow rate should be increased with the EHR percentage to ensure that the required supply flow rate is delivered. Controls will be mandatory on the air handling unit, or you will collect a bonus if you have controls. This is not decided yet. The release of this document is planned to mid-2022, and it will be active from mid-2023. Thank you very much. Please, Håkon.
Thank you, Ricard, on behalf of the audience and TTND members. Thanks for your valuable presentation. It contains a lot of useful information for all of us. So please, I would like to say once again to our colleagues, please write your questions and comments. Also, you can make contributions on the questions tab or chat tab. So I will be asking those questions to Ricard, or you can simply write that if you want us to turn on your microphone, so we can also open it. So beforehand, in the beginning, I would like to ask some questions. So do you expect for the next upcoming eco-design regulation, or based on the existing technological developments, what could be the next minimum efficiency for heat recovery systems, like for rotary wheels and plate heat exchangers and runaround coils? What will be the next?
Yeah, as mentioned there, it will be a little bit different depending on what system you have. But the new calculation depends on the outdoor temperature conditions and if you have humidity recovered or not. As you can see there, here on this slide, in the middle there, you have the calculation. If you have warmer than 14 degrees, but colder than 2.5 degrees. And, oh, sorry, you cannot see my screen. So,
calculation will be changed.
Yeah, the basic is for a little bit different depending on what system you have. So if you have a runaround coil, the baseline is 5% less. And if you have a thermal with moisture recovery, it's 2% higher than a standard condensation thermal wheel.
It makes much more sense. It sounds like a very reasonable and fair method, since those efficiencies are directly related to the climatic conditions.
I think so, yes.
I do also have another question, or regarding to the bypass option, or bypass requirement, thermal bypass requirement for heat recovery options. So sometimes, especially for the heat wheels, it is being confused in our market that when you speak about bypass, sometimes it's requested to have some bypass dampers over the rotary heat exchanger, I mean above and below the rotary heat exchanger, or based on the eco-design regulation, the definition of bypass is different. Could you please explain us?
Exactly.
What do we have to understand for wheels?
What they call here in this bypass is that it should be only possible to turn it off. I think that suppliers usually have on or off regulation, or they have a frequency converter, you know, make it possible to adjust the wheel from 0 to 10 RPM or from 0 to 20 RPM. But if you are able to turn it off to 0 RPM, that is what they call a bypass on the EN 1253.
I'm trying to reach one
plate heat exchangers, they have another system. Yeah, they usually have what we call a bypass, as you explained before.
There is a super long question. It didn't even fit into the frame, so that's why I was trying to expand the frame. Okay, we have a question from Berkay Güçmen from Freeten. I'm reading directly. Thank you very much for your presentation. First question, according to the regulation of Environmental and Technology Ministry of Turkey, by date of 1st of October, the heat recovery systems, which includes runaround coils, have to minimum 68% thermal efficiency. Yes, you already mentioned about it. I would like to maybe emphasize it once again that we are a little bit behind the European Union in terms of following those standards, but thankfully this year in October, as my colleague Berkay mentioned, and now it's officially also released in Turkey. So now the reflection will be to us as engineers, designers, manufacturers, that we have to follow it. So we are not yet aware of the consequences, what will be happen in case we will not be complying those regulations at the moment, but we should keep informing the market and create an awareness about this new regulation also in Turkey, which we have to follow. So the second question or comment is a Eurovent certification program, HRS coils, for runaround heat recovery coils was started by Eurovent. Some of coil manufacturers made applications for the certification. Also, their company completed the successfully completed the efficiency test processes and can answer the demand customers who need to Eurovent certificate. You wrote us here. So most probably the new certification program inside Eurovent will be expanding much more to different suppliers. I would like to contribute to his comment and ask another question. So based on my own experience, so as I have noticed in European countries, when we speak about a runaround heat recovery coil, so usually each coil supplier has their own method, own studies, own design to achieve the requested efficiency. So they use different circuit diagrams compared to a regular or conventional coil. So there are some different tubes entering from one side to another one and jumping over each other. So it's a very mixed circuit diagram. But at the end of the day, based on that complex circuits, they can achieve higher efficiencies. In our country and our suppliers, so it has been started to being developed by several suppliers in recent years, and only by this method it is possible to achieve like 68-70% efficiencies on runaround coils, I think.
Yeah, this is all handled in the supplier's DLL, so you don't have really to care about it.
Presentation will be distributed, and also the video record will be published on YouTube or TTMD's website and social media accounts. So I'm answering to Nuri Bulut. Regarding the COVID-19 issues, would you please indicate the preferred preferred type of heat recovery units? Rickard.
I think with this new regulation, this will boost recovery systems that have humidity efficiency. I think also this will come in Eurovent summer label, so I think this is a future product for heat recovery if you are able to recover moisture as well.
Is there any increase of demand to runaround coils in Europe, especially after the pandemic, since there are like 100% zero leakage? So is there any increasing demand for runaround coils?
No, we don't see this demand yet anyway. The runaround coil usually is used for some special applications in Europe, but we don't see this trend yet, no.
For industrial applications or toxic gases are being extracted.
Exactly. It could also be in some, it also can be some hospitals has this or similar has these requirements.
Mm-hmm. Yeah, it is also very, very popular and very common to use those runaround coils in hospitals in Turkey and our surrounding markets. But sometimes we do receive some questions about designers. what would be the consequences in case we use rotary wheels on hygienic areas? Not maybe in operating theaters, but for some maybe patient rooms or corridors or some other common usage areas in a hospital. What if we would use rotary wheels?
Exactly, and that has to be investigated from time to time, I think. But its producers has more and more advanced system to keep the leakage going to the right direction. There will be a leakage, but you should be able to keep it going from extract to exhaust and not go into supply air. And that is taken care of now if you have a air handling unit with a rotary heat exchanger.
Yes, it's quite critical. And also another quite commonly asked question about rotary wheels is, since they are regenerative type of heat exchangers, which they allow mass transfer also over their surfaces. Okay, let's assume that the leakage is going to the right direction from clean to the dirty air. So in this case, dirty air will not be influenced into clean air. That's okay. But sometimes the question is it possible to let pathogens or other microbiological compounds to grow over the surface? So maybe they are not being transmitted by the air, but is it possible to make them grow over the surface of heat exchangers? So
I understand your question. Yeah. This product has been tested and approved in the different hygienic applications like VD 6022 and others. So the information that test is done so far, there it looks good. I would say yes. No problem with this.
Maybe the critical thing is the difference between molecular sieve and the conventional silica gel rotors, right? I think silica gel is much more weak for those.
Yeah, it will transfer everything, if we put it like that. It's very good to transfer, but it takes everything more or less. And the molecular sieve you can design to only take water vapor by using the 3 Ångström size, pore size. So that is a good solution if you have an environment that requires these limitations.
By the way, dear attendees, we are speaking very generally and openly regarding to different techniques and different options, since they are all available. All those options, all those different types are available in all heat exchanger suppliers. So that's why we are speaking quite open about it. So I'm also checking my own questions if I have missed anything here. So it was also quite interesting from your presentation is that you consider heat pump solutions as a heat recovery solution. This is also confusing that it's an energy recovery, but on the other hand, you do also consume some energy on the compressor.
Exactly, but this system doesn't work if you don't have any energy in the exhaust air or extract air. So this is needed for the system to work, but it's correct. You add some energy, of course you do. Yeah.
So it's a heat pump solution basically. Okay. Checking my questions. What do you think about cellulosic type heat exchangers? So they're also in several years ago they were much more popular in our country, but probably just right after the pandemic they started to lose their fame slightly. What do you think about this?
If I remember correct now, this is the type of dehumidification. You have a warm sector on the wheel that you heat away the
I'm
moisture.
speaking about cellulosic type plate heat exchangers.
Plate heat exchangers.
Based, kind of.
They are coming more and more with heat recovery, yeah. Humidity recovery, sorry. But those one, it's not that famous here in Europe, so I don't actually have all the knowledge about them. But more suppliers are coming with humidity recovery on the plates, but with also this VDI 6022 requirements or tests.
Mhm. Okay. We have another question from our friend Boris Salman. Boris asks that his question is about sorption rotary wheels. Is there any loss of efficiency due to some coating loss during the life of the heat exchanger device, heat exchanger surface? So can we say efficiency is same during the lifetime of the product?
Yes, it's same. There we have seen no difference because the surface, is the same. You can say in times of area, so there's no problem with that. But usually, if you have the same wave height as a condensation wheel, you usually have a little bit less of efficiency, maybe 1% or 1.5% or something like that. But it stays the same throughout the lifetime. Yes, it does.
I see. Okay, so we have more or less gone through all the questions. If you have any more, please ask, and then if not, we can conclude it. Seems like we don't have any other. Okay, so if you have any other questions or comments, so please write below the post on TTMD's LinkedIn account, or you can start a conversation there as well. So thanks a lot once again to Ricard on behalf of TTMD family, and I give the final words to you again.
Yeah, thank you very much. I'm very happy that I could participate in this, and I wish you all the best and stay healthy.
Thank you. Görüşmek üzere arkadaşlar. Bye bye.
Bye bye.